So let's start Chapter 2, Objective 1. It's actually Chapter 2, Section 1, Linear Equations in One Variable. And we're going to look at Objective 1, Solving Linear Equations Using Properties of Equality. So we've got a few definitions we want to go over. So let's define a linear equation in one variable. The key word here is equation. So an equation is always going to have an equal sign. And the literal, the actual real definition is an equation is a mathematical statement that says two mathematical expressions are the same or have the same value. But in our case, a linear equation in one variable is going to have the form ax plus b is equal to c, where a, b, and c are real numbers. And in particular, I guess the most important part about this, because it should come as no surprise that a, b, and c are real numbers, a is not equal to 0. If a is equal to 0, then the first term, 0 times x, is 0, and the variable term vanishes, so we can't have that. And this is a linear equation in the variable x. We could also have a t plus b is equal to c, and that would be a linear equation in the variable t. But for the most part, I mean, x is just a dummy variable. You could choose any letter. For the most part, we're going to use x as our variable. So a specific example is 7x minus 3 is equal to 18. In this case, a is equal to 7, b is equal to minus 3, and c is equal to 18. Now, you're not ever going to be asked to identify the a's and the b's and the c's, but you should be able to look at an equation and say, oh, that's a linear equation, and it's in the variable x. 8x is equal to 0 is also a linear equation in one variable. It can be written as 8x plus 0 is equal to 0, and that has the form of ax plus b is equal to c, in which case b is equal to 0 and c is equal to 0. But that's okay, because our only restriction is that a is not equal to 0. So let's go on to the next concept. The solution set of a linear equation. So the solution set of a linear equation is, let's first define what a solution to a linear equation is. I'm just going to write LE for linear equation because I'm being lazy. That is a value of the variable. So remember, the variable unknowns, they're the same thing, which makes the equation true. So just up above, I gave you the example, 7x minus 3 is equal to 18. Well, let's let x be equal to 2 and see if that's a solution. Well, what I do is I replace x by the value of 2, and I evaluate this side of the equation. 7 times 2 is equal to 14, and 14 minus 3 is equal to 11. And we wanted it to be equal to 18. So x equals 2 is not a solution to this particular equation. Well, let's try another value. Let's try x equals 2, 3. Well, then we have 7 times 3 minus 3. Well, that's equal, 7 times 3 is 21, and 21 minus 3 is indeed 18. So x equals to 3 is a solution. So the solution set of a linear equation, the solution set is the set of all numbers, and of course when I say numbers I mean real numbers. You'll actually see some numbers which aren't real numbers toward the end of the class, which make a specific equation true. So going back up to this particular equation, 7x minus 3 is equal to 18, as it turns out, our only solution is 3. So the solution set is 3. And remember, when we create a set, the elements are placed within brackets or curly braces, and they're separated by commas if there's more than one element. As it turns out, the solution set for a linear equation, there's 3 possibilities. The solution set will either, this is only for linear equations, very important. What I'm telling you only holds for linear equations. Will have, there's 3 options on our menu. 1, exactly 1 solution or 1 element in the set. The example I just gave you. B, every real number is a solution. Or C, no number at all is a solution. In that case, we say that the solution set is empty. And equivalent equations. It's an important concept, but just something to keep in the back of your mind. Equivalent equations are equations that have, can you guess, the exact same solution set. And what our job is going to be is to transform linear equations until we get something like the following. X is equal to b, where x is our variable, b is an actual number like x is equal to 3. In this case, there is only one solution to the equation, and that's the number b. The other possibility is x, for example, I'm going to give you an example right here. For the first, we just had an example, x is equal to 3. Just one solution. This is the solution set. The next possibility is we have a is equal to b, where a and b are not the same number. So there are no variables. A is a known number and b is a number, such as 0 is equal to 7. In this case, the solution set is empty. There are no solutions. You all have 2 options. When you're writing things, for me, you can denote the empty set as just 2 curly braces with nothing in them. But the more standard way is to draw a 0 with the slash through it. And I'm pretty sure that's the symbol that the book uses, and that's the symbol that MyMathLab will want you to use. And the final case is something just like this. X is equal to x, when x is our actual variable. Or something like 5 is equal to 5. In that case, the solution set is the set of all numbers. One way to denote that is to write x. This dash is read such that x is a real number. We have other more convenient ways to write that, but that's what the book uses, and I'll stick with what the book uses. So remember, this is a set. What's in the set? Numbers. What are those numbers like? Any real number is in there. So that's the case when all numbers work. And we'll look at those. First thing we're going to do is to use and introduce some properties that allow us to solve our linear equations. So the first one is going to be the addition property of equality. And if you've done the book reading, and I do please encourage you to read the book material before you actually sit down at a lecture, if you can stomach it. My view is when you get up into the real world and you start looking for a job, you might be given an instruction manual that is, oh my gosh. By reading and trying to figure out math, you've already got a difficult instruction manual, and when you get something new, you say, oh, math was harder than that. At any rate, the addition property of equality, I denote this a little bit different. So if x is equal to b, then x plus c equals b plus c is an equivalent equation. So let's unpack this. So clearly x is equal to b is an equation, right? There's the very important equal sign. Without an equal sign, it's no equation, there is no solving. This states that x is equal to b. So for any real number c, x plus c will also be equal to b plus c. So I just added c to both sides. You can kind of think of it this way. I'm not a very good illustrator. If you have a balanced scale, and our scale has, say, three, whatever you want to call these, marbles or golf balls or whatever. So if it's balanced. So in order, balance meaning equality. So if I add another ball to one side to keep the balance, I have to add it to the other. For example, an actual example, let's say x is equal to 3. If that is true, then x plus 2 is equal to 3 plus 2. I added 2 to both sides, and clearly the solution to this equation is obvious. X is equal to 3. So let's plug in 3 down here. Look, I get 5 is equal to 5. So good job. So that's the addition property of equality. And remember, when we use in mathematics the word addition, we also include the addition of negative numbers, which is known as subtraction. So just a reminder, a minus b is the same as a plus the additive inverse of b. So we're going to be using the addition property of equality and the multiplication property of equality as well. So the multiplication property of equality, slightly different. Suppose, again, that x is equal to b. Now, if c is not equal to 0, and of course it's a real number not equal to 0, cx equals to cb, that's a b there, that this equation and this equation are equivalent. So basically what that tells you is, if I have an equality, as long as I multiply the entirety of both sides by the same non-zero number, I have equivalent equations. So let's actually go about using that in solving some examples. So there's a lot of different ways to do this, and I'm going to use the addition property in a way I don't normally use for example 1 and for example 2. Actually, this is objective 2, and I'm going to do them by objective, so I'm going to stop the video here.